I suppose that we're ready to start. Thank you, guys. Well, my name is Nicolas Sklavos. I'm affiliated with the University of Patras. Actually, I'm an associate professor of computer engineering and informatics department, and I'm here today to present, let's say, to give a talk. In other words, security as a service for next generation and regarding 5G and 6G as a challenge. First of all, I would like to thank very much the first IEEE Next G Summit for the kind invitation and acceptance of my talk, and especially Professor and Dr. Ashutosh Dutta and his team for organizing this successful event. Let's move. This is my presentation outline. First of all, we are going to start with some background of such areas. I'm going to give you some details about the revolution of 5G and 6G, which is coming in the near future. And of course, we are going to study in detail applications regarding 5G and 6G technologies. And last, let's say, but not least, we are going to see aspects and challenges about the 5G and 6G era. In the last part of my talk, we are going to discuss together conclusions and to talk about future directions about these technologies. I think that, let's say, somehow we are a little bit late, so I will be on time as possible I can. Let's say regarding as a background, we can say that, okay, today security is a priority in all means, not only for, let's say, wireless networks, but also for any other kind of communication due to several threats, accidents, which parts of everyday report. Of course, technologies of the near future like 5G and 6G will associate regarding privacy, confidentiality, encryption, and general terms in all layers of communication. And last but not least, we can say that we have increased needs and challenges in such terms because we have several security attacks that are characterized by complexity, strength, capability, and other issues of such technologies. Regarding 5G, we have a lot of requirements, and we do expect the same and maybe more for 6G, such as, let's say, services and application, and also, let's say, special requirements regarding the applied technologies that every subscriber is going to need. And let's move to section 2. In this section, we can say that starting from, let's say, the first generation of security before many years, we can say that we have no encryption at all, but later on in the second generation, we have introduced for first time some security features like authentication, cryptography, encryption, especially for radio interface traffic. And of course, a kind of protection regarding confidentiality that has to do with the subscriber's identity. The next generation, let's say, introduce first, let's say, security architecture model regarding network, user domain security, application security, and also visibility and configurability. Most of us are familiar with, let's say, the fourth generation of wireless networks, and of course, this kind of security that has presented us new cryptographic algorithm, especially with larger key sizes, some new authentication mechanisms, and of course, key agreement protocols, and much more. Here you can see that this is a classical, let's say, model that someone can find, let's say, in the bibliography. We're talking about, let's say, 3 targets. We have confidentiality, availability, and integrity. These are the 3 aims that, let's say, security system, or if you like, a trustworthy system has, let's say, to achieve. And you can see common areas between, let's say, 2 or 3 cycles. This means that, for example, here we have the common area of the 3 cycles. This means that we have adopted a security mechanism that can support the 3 of them. We are talking about flexibility and lightweight resources, so we would like to have security and encryption schemes that at the same time can support at least 2 and maybe 3 of them. Of course, technology is growing up, and here we can say that we have a more detailed model that is introduced and adopted in 5G security. You can see that here we can keep, let's say, the basic targets of previous technologies like confidentiality, let's say, integrity and availability. And also we have the need for new services like centralized policy visibility and much more in the future regarding the 6G. So you can see that the common areas are much more in this time. And of course, it's quite difficult, let's say, to find a common area for all these services and applications, in the sense that we need a lightweight security system that can fit, let's say, the needs for every one of such applications. Regarding the applications, we can say that we are talking about a huge, let's say, a majority of new, let's say, services and subscriptions regarding to the needs of everyone. Here we can see the model of Internet of Things. It's a new world. Maybe someone can claim that, okay, Internet of Things is something, let's say, with one meaning, but here you can see that such an application can be divided into different parts like social IoT, industrial IoT, IoT fog, even if healthcare, smart grids, or other applications like smart houses, smart homes, if you like, in different words, smart water and whatever. This kind of application has to do with different threats, and of course we are looking for trustworthy and flexible solutions, because different domains of IoT introduce different threats. The characteristics of each time, like high density and low latency, sometimes make the solution of security threats to be a great challenge. And of course, we have, let's say, to give answers regarding, let's say, hardware components that we may need, that we are going to address the security issues of all kinds. IoT, and especially 5G technology, is based on a great number, let's say, of sensors. So we need, let's say, an increased level of security in the sense of high security risk. We can give some details regarding 5G and 6G era. Of course, we are talking about the basic target, which still remains cryptography. In different words, we are talking about privacy and confidentiality via encryption, and we have, let's say, a great number of encryption algorithms that can support, let's say, this significant role, like E2E or Snow 3G, advanced encryption standard that still remains, let's say, a very trustworthy solution, and other, let's say, approaches like EPS or also, let's say, new algorithms. Of course, according, let's say, to the standards of the next years, we are talking about, let's say, additional protection in sense of general privacy regulation, or in different terms, the well-known GDPR. And of course, we would like to have attribute based on encryption specifications that are going to be adopted. Authentication is, let's say, the other direction, and has to do with primary and secondary, let's say, development. For example, primary has to do with device and network, mutual authentication, and protocols like 5G ACA, MTA, ACA. Authentication is the secondary role, but also very important regarding data networks and other additional, let's say, schemes like key management procedures. Access control has to do with secure and safe network access, and this, let's say, target sets some very important restriction according to accessibility, some policies, or maybe some mechanisms that have to do with applications. Of course, here we have other proposed solutions like encryption, authentication, and of course, secret key management. And we are talking about a mechanism that have to do with ciphertext-based or IoT access control schemes, accountable privacy and hash access control, and maybe new technologies like biometrics and new password techniques for special and sensitive applications like healthcare, medicine, information system, and so on. Future security issues of such technologies regarding 5G are related to different kind of attacks to the different points of communications like access control, core network, user equipment, and of course that here we have a lot of knowledge I learned from the past, from previous generations, and attacks that has to do with 2G, 3G, and 4G. Regarding communication in 5G, we are talking about a great number of threats like air interface, backhaul device, core network, edge network, and maybe external network threats. The impact to security has to do with network function, and of course, virtualization. Other kinds of this category has to do with network slicing, and also the well-known cloud services and security concepts that may arise from this. Actually, we have to say that we are at a little bit early stage of research regarding 6G. And here we are talking about encryption in sense of security and also resilience. Of course, we need modeling regarding the requirements like network applications. We are talking about principles of zero trust and new aspects and future direction like post-quantum security. According to the research, at least by the moment, we have the need from resilience infrastructure and some other techniques like recovery. Physical security here has to do, of course, with attacks like eavesdropping, hacking, jumping, signal tapping, maybe package injection, and active pilot attacks. And of course, the great target also still remains the privacy in sense of user perspectives. We are talking about services that use more and more shared data, access, let's say, in cutting-edge technologies. Previous speakers today have talked a lot about mechanisms like machine learnings, artificial intelligence, and etc. And of course, since we are moving from place to place and from time to time, we are talking about location privacy regarding multi services for the devices and the location-based services. A great need for the subscribers is identity privacy in sense of confidentiality of identity for each kind of information that is transferred in networks like user devices and also systems. We can talk about some more details regarding privacy. I give you some points because the time is pressing me. And we are talking about end-to-end data privacy, shared environments, trust policies, and third-party issues. And of course, privacy in the part of the users has to do with anonymity, maybe undetectability, or pseudo-anonymity, and other aspects. Let's move to the next section of my talk. What we are do expect in the future, let's say we are talking about cybersecurity modeling in all means, and especially for the forthcoming 6G. We need research and development projects, not only the current ongoing work, but also projects that are going to follow. And of course, many knowledge that has to do with lessons learned from cybersecurity attacks. Just to highlight some points, I think that right here, we are at the crucial, let's say, moment of time that we have to share all this knowledge obtained by each one of us. And of course, according to my opinion and to other researchers, we are not talking about security, but the internets have been moved to trust about communication, trust about devices, trust about services, trust about users. But we have not to forget that in each kind of, let's say, security or privacy or confidentiality or any other services, we have to put people first. Thank you very much. Here are some references that my talk is based on my previous research work of my group. And last but not least, here are my contact details. I'm not sure if we have time for questions, but later on or next days, you can drop me a line or asking a question via email, or even if to come in contact and connect via LinkedIn. Thank you very much, and again, for giving me the chance to be here with you.